The Paleocene or Paleocene, the Old Recent, is a geologic epoch that lasted from about 66 to 56 million years ago. It is the first epoch of the Paleogene period in the modern Cenozoic era. As with many geologic periods, the strata that define the epoch's beginning and end are well identified, but the exact ages remain uncertain. The Paleocene Epoch brackets two major events in Earth's history. It started with the mass extinction event at the end of the Cretaceous, known as the Cretaceous-Paleogene boundary. This was a time marked by the demise of non-avian dinosaurs, giant marine reptiles and much other fauna and flora. The die-off of the dinosaurs left unfilled ecological niches worldwide. It ended with the Paleocene-Eocene thermal maximum. This was a geologically brief interval characterized by extreme changes in climate and carbon cycling. The name Paleocene comes from Greek and refers to the old, new fauna that arose during the epoch. Boundaries and subdivisions. The KPG boundary that marks the separation between Cretaceous and Paleocene is visible in the geological record of much of the Earth by a discontinuity in the fossil fauna, with high iridium levels. There is also fossil evidence of abrupt changes in flora and fauna. There is some evidence that a substantial but very short-lived climatic change may have happened in the very early decades of the Paleocene. There are several theories about the cause of the KPG extinction event, with most evidence supporting the impact of a 10 km diameter asteroid forming the buried Chicxulub crater on the coast of Yucatan, Mexico. The end of the Paleocene was also marked by a time of major change, one of the most significant periods of global change during the Cenozoic. The Paleocene-Eocene thermal maximum upset oceanic and atmospheric circulation and led to the extinction of numerous deep-sea benthic foraminifera, and a major turnover in mammals on land. The Paleocene is divided into three stages: the Danyan, the Slandian and the Thanetian, as shown in the table above. Additionally, the Paleocene is divided into 6 mammal Paleogene zones. Climate. The early Paleocene was cooler and drier than the preceding Cretaceous. Though temperatures rose sharply during the Paleocene-Eocene thermal maximum, the climate became warm and humid worldwide towards the Eocene boundary, with subtropical vegetation growing in Greenland and Patagonia, crocodilians swimming off the coast of Greenland, and early primates evolving in the tropical palm forests of northern Wyoming. The Earth's poles were cool and temperate. North America, Europe, Australia and southern South America were warm and temperate. Equatorial areas had tropical climates, and north and south of the equatorial areas, climates were hot and arid, not dissimilar to today's global desert belts around 30 degrees northern and southern latitude. Paleogeography. In many ways, the Paleocene continued processes that had begun during the late Cretaceous period. During the Paleocene, the continents continued to drift toward their present positions. Supercontinent Laurasia had not yet separated into 3 continents. Europe and Greenland were still connected. North America and Asia were still intermittently joined by a land bridge, while Greenland and North America were beginning to separate. The Laramide orogeny of the late Cretaceous continued to uplift the Rocky Mountains in the American West, which ended in the succeeding epoch. South and North America remained separated by equatorial seas. The components of the former southern supercontinent Gondwana continued to split apart, with Africa, South America, Antarctica and Australia pulling away from each other. Africa was heading north towards Europe, slowly closing the Tethys Ocean, and India began its migration to Asia that would lead to a tectonic collision and the formation of the Himalayas. The inland seas in North America and Europe had receded by the beginning of the Paleocene, making way for new land-based flora and fauna. Oceans' warm seas circulated throughout the world, including the poles. The earliest Paleocene featured a low diversity and abundance of marine life, but this trend reversed later in the epoch. Tropical conditions gave rise to abundant marine life, including coral reefs. With the demise of marine reptiles at the end of the Cretaceous, sharks became the top predators. At the end of the Cretaceous, the ammonites and many species of foraminifera became extinct. Marine fauna also came to resemble modern fauna, with only the marine mammals and the carcharodonid sharks missing. Flora terrestrial Paleocene strata immediately overlying the KPG boundary is in places marked by a fern spike, a bed especially rich in fern fossils. Ferns are often the first species to colonize areas damaged by forest fires, thus the fern spike may indicate post-Chicxulub crater devastation. In general, the Paleocene is marked by the development of modern plant species. Cacti and palm trees appeared. Paleocene and later plant fossils are generally attributed to modern genera or to closely related taxa. The warm temperatures worldwide gave rise to thick tropical, subtropical and deciduous forest cover around the globe, with ice-free polar regions covered with coniferous and deciduous trees, with no large grazing dinosaurs to thin them. Paleocene forests were probably denser than those of the Cretaceous. Flowering plants, first seen in the Cretaceous, continued to develop and proliferate, and along with them co-evolved the insects that fed on these plants and pollinated them. Fauna. Mammals had first appeared in the late Triassic, evolving from advanced cynodonts, and developed alongside the dinosaurs, exploiting ecological niches untouched by the larger and more famous Mesozoic animals. In the insect-rich forest underbrush and high up in the trees, these smaller mammals survived the mass extinction at the end of the Cretaceous, which wiped out the non-avian dinosaurs. Mammals diversified and spread throughout the world. While early mammals were small nocturnal animals that mostly ate soft plant material and small animals such as insects, the demise of the non-avian dinosaurs and the beginning of the Paleocene saw mammals growing bigger and occupying a wider variety of ecological niches. 10 million years after the death of the non-avian dinosaurs, the world was filled with rodent-like mammals, medium-sized mammals scavenging in forests, and large herbivorous and carnivorous mammals hunting other mammals, birds, and reptiles. Fossil evidence from the Paleocene is scarce, and there is relatively little known about mammals of the time. Because of the small size, early mammal bones are not well preserved in the fossil record, and most of what we know comes from fossil teeth, and only a few skeletons. The brain-to-body mass ratios of these archaic mammals were quite low. Mammals of the Paleocene include monotremes, the Ornithorhynchodobdurodon sutamericanum, in the family that includes the platypus, is the only monotreme known from the Paleocene. Marsupials. Modern kangaroos are marsupials, characterized by giving birth to embryonic babies, who crawl into the mother's pouch and suckle until they are developed. The Bolivian Pucadelphys andinus and the North American Paradectes are two Paleocene examples. Multituberculates. The only major branch of mammals to become extinct since the KPG boundary. This rodent-like grouping includes the Paleocene Telodus. Placentals. This grouping of mammals became the most diverse and the most successful. Members include primates, plesiadapids, proboscideans, and hoofed ungulates, including the condylarths and the carnivorous mesonychids. Reptiles. Because of the climatic conditions of the Paleocene, reptiles were more widely distributed over the globe than at present. Among the subtropical reptiles found in North America during this epoch are champosaurs, crocodilia, soft-shelled turtles, paleophene snakes, varanid lizards, and Protoschlydrosangidly. Examples of champosaurs of the Paleocene include Champsosaurus gigas, the largest champosaur ever discovered. This creature was unusual among Paleocene reptiles in that C. gigas became larger than its known Mesozoic ancestors. C. gigas is more than twice the length of the largest Cretaceous specimens. Reptiles as a whole decreased in size after the Kpg event. Champosaurs declined towards the end of the Paleocene and became extinct during the Miocene. Examples of Paleocene crocodilians are Borealosuchus formidabolus, the apex predator and the largest animal of the Wanagan Creek fauna, and the alligatorid Wanaganosuchus. Non-avian dinosaurs may have survived to some extent into the early Danyan stage of the Paleocene epoch circa 64.5 Mi. The controversial evidence for such is a hadrosaur leg bone found from Paleocene strata in New Mexico, but such stray late forms may be derived. Fossils. Birds began to re-diversify during the epoch, occupying new niches. Genetic studies suggest that nearly all modern bird clades can trace their origin to this epoch, with Neornithes having undergone an extremely fast, star-like radiation of species in the early Paleocene in response to the vacancy of niches left by the KT event. Large flightless birds have been found in late Paleocene deposits, including the omnivorous Gastornis in Europe and carnivorous terror birds in South America, the latter of which survived until the Pleistocene. In the late Paleocene, early owl types appeared, such as Ogygopteryx in the United States and Beruonis in France.